Hello and welcome to this Substance Designer tutorial. In this video, we're going to take a look at creating a texture atlas using Substance Designer. In this video, we're going to explore the process behind creating a texture atlas, and I'm going to showcase how that's done here in Designer, as well as introduce you to a tool called Atlas Maker that can help in this process. So what we see here on the screen right now is part of the texture atlas that we're going to create. So here we have several materials like brick, wood, concrete, and so on. And all these materials are composited together to create our texture atlas. And we're going to apply this atlas to our mesh. So let's jump over to Maya and let's take a look at the scene that we're going to be working with. So here we have just this very simple environment scene. And I'm going to use this to demonstrate the overall workflow. So when working with texture atlases, you're going to begin the process through modeling. So you're going to model the environment first. So like I said, this is going to be our environment. Once you have the environment, you would then go through the process of measuring the environment to get the correct pixel resolution that you're going to use for the atlas. And then you're going to apply that resolution to set up the specific tiles in the texture atlas. Finally, once you have the atlas, you'll export that out. You'll bring that into your 3D program, and that is when you'll actually lay out the UVs. So in a sense, it's kind of reverse to what you may be familiar with, in that we're going to lay out the UVs last. So the UV layout comes after the texturing process. Okay, so let's take a closer look at this environment. So I'm going to come over to this level, and I'm just going to hide this, and let's come over here to the level tutorial, and we'll unhide it. And so here you can see that this environment is actually made up of a couple titleable pieces. So here we have this ground, and you can see that it's just a flat plane. Here we have basically the sidewalk and a wall. Here I have a corner piece. And what this allows me to do is just create this environment as this modular asset where we can snap pieces together and just kind of build the environment as we go. So for instance, we have this as a single piece. Here I'm going to adjust my pivot for when I snap this. So I'm going to hold D on the keyboard here, and that's going to put me in pivot snap mode. I can come over to this vertice and just left click to align it. So all I've done there is just align my pivot. Now I'm going to hit Control D to basically duplicate this guy, and I'm going to hold down the V key, so this puts me in snap mode here, and then I'm just going to just snap this guy into place. So you can see that here I've got my two pieces. I've just snapped them together. This is what is referred to as kind of building on the grid, in a sense that I'm building these to specific measurements or units that can be snapped together or aligned. And so, like I said, you can see that we've got this piece, we've got this piece. Here's another corner piece, again, that just kind of snaps together like this. If we were to just rotate this corner piece, we could just further build this guy out here. Again, this is kind of our ground, so if I want to just hold down the V key to go into vertex snap mode, and then here I'm just going to snap this guy into place. Actually, forgot to duplicate it. So here, let me just Control D, we hold down the V key, and here we snap this guy into place. And you can see it's really easy for me to kind of just build up these elements. So for now, let's just kind of delete these guys because we're just going to look at this piece by piece to start. And so, like I said, you start to kind of build these objects up. They're built to a specific scale. And then once that's done, we need to measure this geometry scale. So first, let's take a step back and talk about the scale. So I'm going to enable my grid here so we can kind of see what we're working with here. Actually, that's just getting in the way. Let's just disable that grid for now. In terms of scale, this is something that you're going to set up for your project. And then you're going to take this unit size, whatever you determine to be your scale, and then you're going to set that to an actual pixel resolution. So you want to basically establish a ratio between geometry size and pixel resolution. Now, what I have done for this is I've determined that for every unit that I'm working with, every unit in my 3D world space here, it's going to equal 256 pixels. Now, in the case of this demo, I just made that up. So I just arbitrarily came up with 256. How you actually come up with that number depends on several factors. It depends on things like, what's your texture budget? What type of scale are you going to be working with? Is it, very large, very small scale, and so on. So that's something that you determine based on, just, working up, just some prototypes, just kind of seeing, how things go, how your game needs to be optimized, and so on. In my case, just for this example, like I said, I just came up with the arbitrary ratio of 1 unit is equal to 256 pixels. So here in Maya, the way I do this is I will come over to my settings. So I'm going to hit the space bar and I'm going to go to Windows and Settings, Preferences, Preferences. And then here underneath my settings, you can see that for my working units, I set this to meter. Okay, so like I said, I've already gone through and just kind of modeled out this geometry. And I'm going to take this wood here and just move this guy out of the way because we're only going to be thinking about this section right here. And so what we have is we have a wall, then I have like this sidewalk piece here, and then I have this kind of little concrete piece here for the base of the wall. So basically we're going to have 3 materials: brick, concrete, and then this other concrete, sidewalk concrete. And these are all going to be placed in my texture atlas. So first thing I want to do is I'm going to work on the tile for the brick. So like I said, the process becomes that, you know, I have my scale, and now I want to establish that ratio to the geometry scale to the pixels. And so what I'm going to do is use my distance tool here. So let me just grab this locator. I'm going to hold down V to vertex snap this guy, and I'm just going to snap him into place. So here you can see that I've snapped it to that vertex here. Now let's grab this other guy here, and again let's hold down V and let's snap him to the top. And so now we're just taking a measure, a vertical measurement of what this brick wall is going to be. So here you can see that this is 4.26. So now let me just grab my calculator, and so we're going to read this as 4.26. I'm just going to say 4.2. So let's do 4.2, and that's my units. And we're going to multiply this by my pixel resolution that I'm setting here. So again, that's the ratio that I just determined for my particular project settings. And in our case, that's going to be 256. So what we have here is a pixel count of 1075. We'll forget the 0.2. So 1075. That means that for this wall here, we're going to place vertically a pixel count of 1075 pixels. So now let's we've got the height. Let's do the width. So again, I'm going to hold down V, and I'm just going to snap my tool here so that we see what the horizontal measurement of this is. And here we get 3. So that's going to be 768. So again, let's just grab my calculator. If we take this again, so this is our units. We're talking about 3 units. And we're going to multiply this by 256. So here we get 768. Now again, remember we said 1 unit is equal to 256 pixels. So again, that's why we take 3 times 256. So now what we're looking at here is a width of 768 pixels and a height of 1075 pixels for this brick area. And what that does is it takes our geometry size and it establishes an exact pixel count for that geometry size. And that becomes a very, very efficient way of working. Now, I had talked before about, well, how do you come up with this, 1 unit equals to 256? And again, of course, the answer is never very clear. It's, it depends on a lot of factors. But, another thing to kind of think about with this is, how close is the camera going to get to this type of geometry? So let's just say that in our case, the character's never going to get like really close up on this wall. It's never going to be a view like this. This is, for some reason, this is something that we'll see kind of far away like this. And so if we determine that for that camera focal length for that, that 1 unit to 256 looks really good for what we want to do, that's good. Or maybe we could get away with 1 unit is equal to 128 pixels. That means that we could have, smaller tiles for some of this geometry. Means we can pack more into the texture, which means, we're still only using that one texture, basically for all of these materials. Now, I say one texture, of course, as you'll see, it's going to be base color, rough, metal, and so on. It's all going to be, several channels that's going to make up that same material. But again, we're packing all this into this major atlas. And so, again, it just depends on, what your needs are going to be for that. So like I said, at this point, we've gone in and we've determined the width and height pixel count for just this single piece of geometry. Now what you would do typically is go through and just measure your scene, write everything down of how this is going to work, and you'll have everything set. And then we're going to now jump over to Substance Designer, and we're going to start to build this atlas. And then, like I said, once we kind of get this going, we'll come back to Maya and we'll do some more measurements. But now let's jump over to Designer and take a look at how we can use this information to start to build our texture. Okay, so before we actually start to build up our texture atlas, I want to talk a bit about the Atlas Maker tool. So this tool is going to be the utility that we use to create this atlas. So let's just come over to kind of an empty area here in our graph, and let's just left click, drag and drop an instance of Atlas Maker, and let me just kind of showcase a few of the important aspects of this tool. So this tool is going to take a material as an input, and it's going to output a material and a mask. The idea is that it takes the material, it's going to mask that material based on this tile mask that you set, and then it's going to output that material that allows us to then layer that material using material blends, and we're going to utilize this mask to help us do that. So when you start working with Atlas Maker, the first thing you're going to do is define the resolution here for the tile. And you're going to get that information just as we did back in Maya, where we measured our geometry to see what the exact pixel resolution we need for that specific area. That's going to be represented here in our texture atlas. So before we actually get into the tile mask, I want to discuss a bit about how this works. So the tile that you create, you're going to actually utilize pixel values to set the tile resolution and its offset. And we have this resolution guide. So when we hit this drop down, you can see that we got several resolutions that we can work with. And this resolution guide, this isn't how we resize the actual atlas itself. So the atlas gets resized just as any other node does inside of Substance Designer. And so we can work with dynamic resolution. And it's very cool how the atlas will retain all of the alignment as the document is resized. And I'll show you how that works here in just a bit. But what I want to bring your attention to is this resolution guide and what it actually means. So all it is it's a guide. It's basically saying this is going to be the resolution guide that I use for the pixel information that I place here. So the pixel information, again, is relative to what it is we place for this max resolution guide. So for instance, here you can see that we have a tile here that's at 512, 512. Let's take this and set this to actual 1024 by 1024. So you can see that it takes the node's resolution and it does change it. So here we're at 1024 by 1024. Now, when we do this, you can see that our tile, which is indicated here by the size, it's at 512, 512. That means we have a tile that we're working with right now that's a 512 by 512. If we were to take this guy here and let's just give it another size, let's say like 1024, so you can see that now we have the tile covering on the x-axis, or horizontally, 1024 pixels wide by 512, and this is kind of the tile that we get. So let's go ahead and take this back to 512 here. Now we can also start to work with an offset, and we're going to work with this offset in pixels. So if I wanted to say take this tile and place it on this other side here, or if we think about dividing this 1024, 1024 into a quadrant or 4 sections of 512 tiles, we can do that offset by just coming in and typing, let's just do this here, 512, and that's going to align that second quadrant there. So it's basically placing it flush here into this second quadrant. Now, the way that this is actually working is based around this alignment mode that you have, which is called Edge Justify. And so by default, Edge Justify is on. And all this means is that whenever we work with our offset value, it's going to align itself to the edge. If we were to turn off Edge Justify, so I'll do that here. And here, let me do this. Let me turn on Edge Justify again, and let me set this X value. Let me set the Y value to 512 as well. Now again, when we do this, that means we're going to offset. So we offset to start 512 pixels. Now we're going to offset down in the Y 512 pixels. So when we do this, this is going to put this shape down here into this lower quadrant. And now when we turn off Edge Justify, it'll place it right here into the center. And that's because with Edge Justify off, the alignment is taking place on the center of the tile shape. With Edge Justify on, the alignment is taking place on the edge here of the shape. Now, the way that the resolution is being calculated in terms of an origin, you can think about the origin being 0, 0 here at the top left. And so we're going to offset by this amount. So at this point, we've set up a tile, so 512 by 512 pixel size tile, and we've offset it to an area on our map, our 1024 map, to be 512 pixels on the X, 512 pixels on the Y, and this is where we get. Now, this all works because at this point, we're relative to this resolution guide of 1024. Now, if I were using these specific size and offset values, because this is the way I want my tile to work, but if I was using this and thinking about it in terms or being relative to a different resolution, then we're going to get a different result. So if I change my resolution guide to 2048 and I back this out, you can see now we're getting, you know, a completely different value. So if I wanted to fix this to be a similar layout, I'd have to obviously change my pixels because I'm working with a higher pixel count now. So it would be something like 1024, then we would do 1024. Now we're going to offset this here by 1024 and 1024. And so this gets us here into the correct layout for the resolution guide of 2K. So you can see that changing this, now here's another, on the flip side of that, let's say that, you know, this is the pixel information I was working with when I was using 2K as a guide, but if I switch my guide, but I don't switch my pixel count, this is what I get. So a completely different layout altogether. So what's important to understand with this is that the resolution guide, you're going to set this to the max resolution that you will be using for your atlas. Now, again, this just pertains to, you know, the values that we're entering here. This is not about how we actually resize the actual atlas itself. Let's take a look at how that works. So here, I'm going to come over to this final node. This is my actual atlas here. Let's double click kind of an empty area here in the graph, and let's go up to our base parameters, and let's take a look at what this output size is. So you can see that by default, I'm working with an absolute output size of 2048 by 2048. Now if I switch this to a lower resolution, so let's do this. Let's do 1024 by 1024. So I'll resize the graph. You can see that the atlas is being recomputed. However, now we're at 1K by 1K, but you know, everything is still retained in the correct size ratio. Everything's still aligned perfectly. Everything is fine. We can take this down to 256 by 256, and we're going to get the same thing. Everything is still aligned perfectly to what we need here. So let's take this guy back up to, let's say, 1024 by 1024, and we're just recomputing our graph here, and this is what we get. So you can see that the atlas can be dynamically resized, which is really cool, and that we can resize that atlas yet still retain all of our alignment that we had set in our atlas. And that is because, again, you know, we're working off this, we're letting the actual offset values that we place, you know, they're driven off this kind of resolution guide, but the actual resizing of the atlas itself is based on the graph. Now, another thing you have to be careful about is, again, think about in terms of your max resolution. So like I said before, you know, this graph was at 2048, but let's say that, you know, this final texture atlas I'm creating, let's say that, okay, it's the max it's ever going to be is 1K, okay, and that's what it's going to be. Well, if I let the atlases, and so here's one of them here, if I let them stay at 2048, you can see the situation you can kind of get into where, you know, the final output's going to be 1024. Most of the nodes are processing at 1024, but all of the atlas nodes are processing, you know, at a higher resolution here. So this becomes kind of an unoptimized way of working. So that's why you would probably set this resolution guide to being whatever that max resolution is going to be. So notice here, I didn't set these guys at 4K because I'm not going to do a 4K output. I'm only going to do a 2K as my maximum. So I'm coming back to my base, switching these guys to 2048 by 2048. And everything's recomputed, and we come down, you can see that all my nodes are at that resolution. But if I did want to change the output down, I can still do that and still get 1024 textures. The only thing is you might get a small hit in computation because we do have a couple extra higher nodes that are being locked at 2K and so on. So anyways, it's just something to think about in terms of how that, that resolution guide here is going to be working, and how you need to set that appropriately to start. Okay, so that kind of covers, the basics of what I want to kind of show with how that's going to work. So now let's go into the actual process of creating our atlas. So I'm going to come into our nodes here, and let's just go and just delete all these guys that we have here. So let's just start over. And here's my outputs, and here's my node. We'll just kind of zoom in, and let's select this guy, and let's get started here with what we're actually going to be working with.